Hi everyone. We're going to find the radius of convergence and interval of convergence for this given series. We're going to use the ratio test and look at condition 1 for the ratio test. So we're going to take the limit as n approaches infinity, and we have a sub n plus 1 divided by a sub n, absolute value. Okay, so substitution would give us, when you substitute in n plus 1, I want this to be a little smaller. All right, everywhere there's an n, you put n plus 1, so we're going to get absolute value of 2x minus 1 to the power of n plus 1. And then the denominator is going to be 5 to the power of n plus 1 times the square root of n plus 1. And now we have to deal with a sub n. And instead of dividing, we're multiplying by the reciprocal because it's the same. So we're going to get 5 to the power of n times square root of n divided by 2x minus 1 to the power of n. Okay, now let's simplify this. If I look at this piece, this divides out, the n's will cancel if you use your quotient properties of exponents, and you're going to get absolute value of 2x minus 1. Then if you look at this piece, this is going to go to 5 to the power of negative 1. So you have 5 to the nth minus n minus 1. So that's going to put us 5 in the denominator. Then we're taking the limit as n approaches infinity of square root of, this should have been n divided by n plus 1. And this is the same as 1 divided by n divided by 1 divided by, you divide every piece by n, you're going to get square root of 1 divided by 1 plus 1 over n. So this is just going to go to 1. So our answer is, this equals absolute value of 2x minus 1 divided by 5. So it converges by condition 1 of our ratio test if this is less than 1. So this only happens, and if you can cross multiply, when you have the absolute value of 2x minus 1 is less than 5, or you can write x minus 1/2. Absolute value of that is less than 5/2. I just divided each piece by 2. So that happens when we have, by definition of absolute value, that happens, and I'm going to erase this piece here, when we have negative 5/2 is less than x minus 1/2 is less than 5/2. So when you add 5/2, when you add 1/2 to everything, you're going to get negative 2 is less than x is less than 3. Now what we're going to do is test the endpoints. So your r equals 5/2. And now we're going to test the endpoints for our interval of convergence, which is negative 2 and 3. So testing those, when x equals 3, we get the series n equals 1 to infinity of 1 divided by square root of n, which is 1 divided by n to the 1/2. Now this is convergent if p is greater than 1. Our p equals 1/2, which is not greater than 1. It's actually less than 1. So when x is 3, this is divergent. Now let's test when x is negative 2. So we have x equals negative 2. We're going to get the series n equals 1 to infinity of negative 1 to the power of n divided by square root of n. Now this does converge by the alternating series test. Therefore, the interval of convergence is for -2, it does converge. So we're going to put that as a closed interval. For the 3, it's divergent, so you use open interval. So there's your interval of convergence. Thank you. Have a nice day. Bye-bye.